Okay, one is to read it. It says let f, an f some function, by the way, and they say the real numbers, such that the real numbers are greater than zero, that's positive numbers, are being mapped to the real numbers. And then it goes on to say where, that symbol over there, and let me just outline that for you. Looks kind of odd, doesn't it? Is a set of all positive real numbers, all right? They also go on to say it's differentiable, all right? It's differentiable. And they said this relationship's going to be held for all x, y that are real numbers. I'm sorry, that are positive real numbers, all right? Furthermore, they tell me this. They tell me its derivative is equal to 1. But then they ask this question over here as a computation problem, all right? I do recommend, that's a hot link over there, I do recommend you watch this guy do it. And I believe the question comes from a competitive exam that's given to students in California. I think it's open to a lot of students, but not just California, if they can get there. And it's at Berkeley. And I think they're high school students that are certainly taking calculus, and they find that mathematics is an enjoyable recreational activity. At least I hope they do. They're not being tortured by it. So over here, what I want to do is I want to go to the whiteboard. But again, I want to point out to you, a video will be published when I get to it. And this is the video we're making now. And then, the bottom line is there's a blue area here, me working through the problem. All right? So, and coming up with an answer on it, blah, 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 blah. What I want to do is go to the whiteboard, though. And the problem with this is understanding what you just read. All right? So first thing I'll write down what I read. And it says, f of y minus f of x. I'll get to their question later, by the way. But I want to kind of understand what this is giving to me over here. It's x to the x, and then I get y to the y times f, and then I'm going to put y to the y, and then x to the x. Now, granted, some people have a natural talent for looking at things and realizing what the function is by looking at it. I don't possess such a talent, by the way. But what I want to do is I want to, kind of plug in numbers initially. And what I'm going to do is, just to get the left side to be 0, I want this to be 0. I want it to be 0. So let this side be 0, all right? The only way I could do that is if x is equal to y, and I got to pick a number that's easy now, all right? Like you could pick 2, but I'm looking at this thing over here, and by the way, I know x and y have to be positive numbers, so I'm going to pick a number for me that's easy to do. I'm going to say 1. But you could have picked 2, by the way. 2's not that bad, all right? I'm not saying it would help you, but I'd say the easiest number to do. Let's write this down. F of 1 minus f of 1 would be equal to 1 to the first power, 1 to the first power, times f, 1 to the first power, 1 to the first power. Well, I do get 0, because f of 1, whatever it is going to be 0. 1 divided by 1 is 1, and f of 1 divided by 1 is f of 1. So I'm going to say over here, this might be useful, but it may not be useful. Maybe I got to do, f of 2 or f of 3, whatever. I don't know. And you could do something like that, all right? All right, let's keep going. And let's see what happens over here. By the way, I just thought to myself, even if I were to choose, x equals y equals 2, I'm really going to get the same thing over and over again. And why is that? You'd get 2 to the 2, 2 to the 2, f of 2 to the 2, 2 to the 2. And what are you going to get there? 0. You get 1 over here, and you get f of 1. I'm getting the same thing every time, by the way, no matter what number I choose over here, provided I'm choosing those x and y greater than 0. So that's kind of an important fact at this point. It's kind of interesting, isn't it? All right, let's keep going. So what I want to do is, probably set to a different thing now. And what I'm going to do now is I start to realize, and look at this over here. I'm realizing this over here. Now let me tell you what I think I'm noticing. I'm looking at the left side. I'm looking at this. And this sort of looks like a derivative to me, but not really, because I'm missing things. And there's many ways to rewrite it. But what I'm going to do is I'm going to let y equal x plus h, with the understanding that I want, this thing to be greater than 0. Get my eraser out again. Now, granted, I know x and y are greater than 0, but I certainly want x plus h greater than 0. All right, so let's write this down. And I'll write down f of, well, y is going to be x plus h now, minus f of x. You may wonder why I did that. I want it to look like a derivative. And part of the reason I want to make it look like a derivative, they've given me a derivative problem. They said f prime at 1 was equal to 1. They actually gave that to me. All right, put a little box in this as a given. I'm trying to get a derivative out of this thing. So why don't you just take the derivative? Well, I'm looking for something that maybe make it easier from taking a derivative, because the derivative looks pretty tough. All right? So what do you get over here? Well, you get x to the x. And then what do you get in the bottom? Well, remember, y is x plus h. So I get x plus h to the x plus h times f, let's see, x plus h to the x plus h, and that's over x to the x. All right, so I'm going to say that's relatively simple, but I still don't have the derivative, and what I need to do is divide both sides by h now. All right, so what I'm going to do is I'll write this over here, f of x plus h minus f of x. I'm going to divide the left side by h, and I need to divide the right side by h. I'm sorry, this is x plus h. All right? Now what do you get over here? I'm going to do this and write this one a little differently. I'm going to write as f of x plus h to the x plus h over x to the x. And then on bottom, what are you going to get? You're going to get h. So I divide both sides by h. The next thing I want to do is I want to do the limit. The limit as h approaches 0. Yeah, I got to write this over again, don't I? F of x plus h minus f of x over h equals the limit as h goes to 0. And you know, I got a product here, and they say these things are differentiable, so I'm just going to say, let me just differentiate. And not differentiate, but let me just take the limit of the product now, because these are nice functions, right? So limit h goes to 0, and this would be x to the x, and this would be x plus h to the x plus h, and this can be f of x plus h to the x plus h over x to the x, and you get h in the bottom there. All right? So the left side looks pretty simple, and I'll tell you why it looks simple to me. It just looks like the derivative to me. All right? What is the derivative going to be? F prime of x. Now the right side, I'll be honest with you, it doesn't look that simple to me, but one of the guys looks easy to me. For this one over here, what happens there? Well, as h goes towards 0, I would be left off with x to the x over x to the x, which would just be the number 1, times the limit as h goes to 0. Right, this is like a little longer, right? H. And then right over here is this is going to be f of x plus h to the x plus h, x to the x. Oh boy. Well, it's certainly true what I wrote down over there, but what I want to write down over here is I want to write down this to look sort of like a derivative. So I'm going to say minus something here. I'm going to say minus 0. I haven't changed it, by the way. Now, here comes my problem, by the way. I'm going to keep writing this over again until I see something. This is the limit as h goes to 0. Put an h here. I'll write down f. And this is going to be x plus h to the x plus h over x to the x minus f of 1. It's the same thing as 0, by the way. All right? So I would say this is the part, and again, when I watched the guy's video too, that's the part where he got stuck too, by the way. And then, I'm not going to say he cheated, but it's not cheating, by the way, to look at, say, give me a hint, give me a hint. And he did that. And the hint sometimes is just a glance at something. And this is what teachers get so upset about when you glance at someone's paper. It could actually set the tone of what you're going to do next, by the way. And that's what he did. He glanced at something. And what he did was he wrote down what they gave him. And what they gave him this over here. Now, what would that be? And I'll write this down in a couple of different ways, by the way. It's going to be the limit. You could write down as h goes to 0, by the way. And what would that look like? Again, just using a definition derivative, it would be f of 1 plus h minus f of 1 over h. Yeah, you could certainly write that one down. That's the definition of a derivative. You could also write down limit as x goes towards 1. And what would this one look like? It would look like f of x minus f of 1 over x minus 1. All right? And again, looking at it, again, I know these things are 1. All right? I know the limit's going to be 1, by the way. And, you know, I'm going to look at these things, and this is the part where I'm going to say it's a jump in reasoning. And so I got this part written down. Whoops, sorry about that. I got this thing written down. I'm looking at that. I'm looking at these guys over here. I'm wondering what to do now. All right? And looking at that, take a look. Be careful about that, right? Well, you know what I'm going to do? I'm going to do this over here. Oops. Did it again, didn't I? Limit. Write this a little differently, by the way. I'm going to write it as f of something minus f of 1 minus 1. And then I'm going to put this crazy looking thing down, which is x plus h to the x plus h over x to the x. And then this thing here would have to be the same thing now. But I want to make sure that's going towards 1. I want to make sure that thing's going towards 1. And one way I could do that is by making, let me see if that's true, by the way, making the h go towards 0. If the h goes towards 0, that would be 1, right? Because you have x dx over x dx, and that would be 1. So that stands to reason, by the way. I'm kind of looking at this now and wondering what to do next, right? Looking at this, and h goes to 0. Let me think. Again, I'm looking. And this is equal to 1. That's an important fact, by the way. And what I know about these things over here is when h goes towards 0, both of these things are going to the same thing. Right? They're going to the same exact thing. That means I got to think. And they're both going towards 0. So I think I could probably write down another limit. I'll put that one down for you. The limit as h goes to 0. I'm kind of looking around. This is really the tough part. It's going to be, I'm going to say h now. It still goes to 0 on the bottom, by the way. And then I'm going to say, you know, this thing and this thing are identical when you're going, h is going towards 0. So just write this down on the top now. Okay? All right, what do you do with that? It's getting a little better, though. I'll say that. I know it's going to be equal to 1. And my goal over here is to do that limit. Let me see if I can do that. And let me just think about that for a second. So I got that. Let me go backwards. I'm thinking about what to do with that instead. Well, you know what? I guess I could write this down as f of x instead now. Let me just think about that for a second. The derivative of that. Where's that coming from? Right over here. Let me see if I got that. Yeah, I do have that. All right. So I'm going to say it's f prime. Let's write this down. It's an interesting fact, isn't it? Fact is, can I do that limit? And one thing I know about limits, h goes towards 0. So let's I'm going to multiply top and bottom by x to the x to the x. Let me keep writing this down now. Limit, h goes towards 0. That's going to be h, x to the x. On top, you're going to get x plus h, x plus h minus x to the x. All right, I'm going to keep looking at that. Well, one thing I noticed about this over here, I could pull this out. I'm going to do that now. And that's going to be 1 over x to the x times the limit as h goes to 0. Looks like a tough limit, doesn't it? But I'm starting to recognize this guy over here as being the definition of the derivative of this thing. And what would you get? X plus h, the x plus h minus, yeah, it's the same right thing, exactly that, all right? Now what do I got over here? I got something over here, I'm removing the limit symbol now, x to the x times the derivative, and it's going to be f prime of x, by the way. It's going to be the derivative of x to the x. Now granted, this is not something I remember offhand, by the way, but I do want to get its derivative, and I'll kind of like, you know, I'll do some side work, because I can't remember that guy's derivative. I'm going to say y equals x to the x. I take log of both sides, natural log, and you get x ln x. Take the derivative of both sides. That would be 1 over y, and that would be dy dx. And then the other side is going to be, you know, x times 1 over x plus ln x. All right? So what do you get? You get dy dx would equal y. Well, y is x to the x times, the first term would be 1, second term is natural log of x. So I know what that's equal to. Let's write that down. So f prime of x is the same thing, 1 over x to the x times, well, I'm writing this over here now. Let's put that down. So what's that going to be? It's going to be x to the x times 1 plus the natural log of x. This cancels off. That's if x is greater than 0, by it cancels off. And you get something pretty simple, by the way. And you get 1 plus the natural log of x. All right, now, what am I trying to really do? Someone said, I forgot what you're trying to do. I'm really trying to find f because I need to evaluate f of numbers. So the way I'm going to do that is just integrate both sides. I'll put this over here. F prime, that's with respect to x, equals, it's going to be 1 plus the natural log of x dx. Well, I can do the left side pretty quickly, by the way. Just simply f of x. I know it's going to be a constant, but I'll put it on the other side, by the way. The antiderivative of 1 is 1. I'm sorry, x. And then I do remember the antiderivative of natural log of x. So the antiderivative of natural log of x is going to be, you do it by integration by parts, by the way. It would be, I got to remember now. I think it's, I got to think. And I think it's x. I'll check it though. ln x minus x plus some constant. Now I want to check it before I write that down, by the way. And how would you do that? I guess we just sort of did it before. It would be x. I'm differentiating now. 1 over x plus ln x minus 1, derivative of c is 0. This is 1, that cancels that. And yeah, I get it. So I got that over there. So let's write that down. So it's going to be x ln x minus x plus some constant. I have no idea what the constant is at this point. But f of x is going to be equal to x ln x plus c. All right. Now, do I know a value? And I do. I know f of 1 is equal to 0. That's the first thing we did for the problem, by the way. It was easy to do. So what I can write down now is I can do that. So I can say f of 1 is equal to 0 is equal to 1 times the natural log of 1 plus c. Well, the natural log of 1 is going to be 0 because e to the 0 is 1, by the way. So what do I get over here? I get this is going to be equal to 0 plus c. So what does that mean? C is equal to 0. So now I found f of x. F of x is going to be x ln x. All right? Again, important. Right? Now, why is it important? I need to evaluate something. And I need to evaluate this. I need to evaluate f of 2020 squared divided by f of 2020. Let me write that down for you. What's it going to be? 2020 squared times ln of 2020 squared over 2020 times the natural log of 2020. I'm going to simplify. And the first thing I do is I notice that 2020 squared over 2020 is 2020. And then I notice this log is going to be 2 times the natural log of 2020. What's on bottom? The log of 2020. Well, I don't know what the log of 2020 is, but I know they're the same number. They're non-zero, by the way. They cancel off. And what do you get over here? 4, 0, 4, 0. And this is the end. Thanks for paying attention.